All right, first of all, I do for the first 2 weeks and the 2 weeks only, first 2 weeks only, go with a reminder each day before classes begin. After this week, then you're on your own. It's expected you know how to read the syllabus and you know how to read a calendar, and you can tell when your due dates are due. So your email associated with the syllabus quiz is due Thursday. Your syllabus quiz on D2L Brightspace is on Friday. There was Mastering Chemistry Extra Credit that was due already yesterday, and another one tomorrow. And your Chapter 1 syllabus, or Chapter 1 homework quiz is due tomorrow as well. Any questions on the syllabus? Going once, twice. All right. Next up, last week in lab was the required safety training. If you missed the safety training last week, please see me here immediately after class so I can tell you what you need to do. And just real quick, anybody in that situation or they missed lab last week? Okay. Have you got an email on that yet or no? No? Talk to me after class. We'll fix it up. Do need a lab notebook before your lab this week. Make sure you get that. Remember that does need to be a bound notebook. Anybody? Yeah, you have one just like it. Bound notebook. Right here, or something like this. Your bound notebook. Thank you. Socrative app each day. Questions will always be waiting for you. We do have an element quiz a week from today, September 5th. And remember, 2 things required on your element quiz. You need to know symbol and the spelling. And the spelling has to be correct. So again, name of the element. Remember that the symbol first letter is always capitalized, second letter is always lowercase. If I can't tell the difference in case, it's wrong. It is possible, I mean, if we do it in here, the intent is to do it at the beginning of class. I'll make a judgment on it. If we're not getting that, then I throw it up on D2L, and it's a 5-minute time thing on D2L, and you'll get about 20 randomly assigned symbols or names of elements on there. So we'll just kind of look at it. I'll have a good feeling here Thursday once we're done whether it's going to be an in-class thing or a thing on D2L. So again, if it's on D2L, it's a 5-minute time thing. You need to know the ones that are highlighted in gray. All right, any questions on those? And then Mastering Chemistry, did ask here before class a bit if anybody's having trouble with it. It sounds like it's pretty self-explanatory, everything. If it's not, I do have a video or a slideshow there that shows you, walks you through it. And if you're having trouble, it's because your pop-up blockers are turned, whatever they are, the wrong way. You want to turn them off if you want to get it to work. So, all right. Well, let's get going here today and look at your answer to the first question. Answer the first question with the correct number of significant figures was 0.46 grams per cubic centimeter. Then the meter, right here, this is the closest to which one?
Yard.
Yard. Yard is how many inches? 36 inches. A meter is a bit more than 39. In terms of this one here, this is a liter. This is closest in size to a quart. A quart. Closest in size. Now, anybody know what the SI unit is of volume? SI unit of volume.
Liter?
It's not the liter.
Decimeter cubed?
It's a meter cubed. Yeah, it's a meter cubed. And so, if we go back to the table we looked at in our last class period, at least I think we had put it up here. I was talking about SI base units. Talks about the meter as being a unit, SI unit of length, but derived units don't appear up here. And I think, I guess we talked a bit about that a cubic decimeter and a liter. Did we talk about that?
We have notes on the right.
Yeah, the notes on the right. Okay, so that's what I thought. I don't remember it, as things are just so foggy here these days. One of the things maybe we didn't mention in here is that if I take this box apart here, any idea how much each of these little cubes is?
Centimeter cubed.
Centimeter cubed or a milliliter? Okay, and sometimes these are often mixed up with each other. But what I'd like for you to know here is this: is that in this liter we have 1,000 cubic centimeters. We also have 1,000 milliliters, which means that a cubic centimeter and a milliliter are the same thing. And what's another way we write a cubic centimeter? If you have a motorcycle, you know, measured in cc's, right? So here are some conversions you need to know. You need to know that a cubic these ones that are boxed, that a cubic decimeter is the same as 1 liter. You need to know that a cubic centimeter is the same as 1 milliliter. And what's kind of interesting is this: when I was sitting in your chair, you know, I don't know, 30 years ago or whatever, it's actually more than 30, believe it or not, I had been contemplating a career in the medical sciences. Turns out if we went to the doctor at that time and you were going to get an injection, those injections were measured in units of cc's. Today, if you go in, you get an injection there measured in units of milliliters. Any idea why I changed from the use of cc's to milliliters? Even though they're the same thing. In fact, I can bring out a couple syringes here right now that I had out earlier today. Here we go. If I bring out these syringes and show you. Here is an older syringe right here. This older syringe, you'll see, has units of cc's on it. This newer syringe has units of milliliters on it. Any idea why the change? Well, see, what does the prefix centi mean?
100.
1/100th. The prefix milli means 1/1. Did I say this wrong? Milli? You don't know those yet? What is milli?
Million.
Yeah, what does it mean? 1/1000th. Okay? So yeah, dang, you know, if you guys don't have this yet, it's like bad on you, all right? Let's get those things down, because I don't like to swear, all right? Just like I don't like to drink beer when you guys, we talked about that, right? So I like to drink beer, but I don't like to drink a lot of it. So we need to get these things down. So if you don't know these prefixes, let's get them down. Maybe that's what I forgot to mention. You need to memorize these prefixes, the ones here in the bracketed area, and you need to know what their meanings or multipliers are. So the big issue is that when you convert a length cubed, you look at it as a volume, prefix centa stands for 1/100th, where milli stands for 1/100th. So what was often happening is that people had trouble converting units. And when you have trouble converting units and you're in the medical profession giving dosages, what do you think happens to patients? You die. You overdose them, right? So to be consistent then, we wound up using the prefix milli to go with liter to make sure that we're using the 1/1000th that it's supposed to be, where some people, if they're using the prefix center, were using 1/100th as the conversion, when there's 1,000 cubic centimeters in 1 liter. So a little history behind how that came about to be used. Even though they're the same thing, the usage today is milli rather than centi. So these ones that are boxed are ones you need to know. And then you should know all of your metric to metric conversions that are shown on here. So again, know your prefixes. The conversions that are on this sheet are ones that will be provided for you on all exams. So you are going to be provided with English to metric conversions, and you're going to be provided with English to English conversions. The reason why you memorize the metric to metric ones is because I can't give you all the conversions we'll be doing with that, because if we learn the SI units, the centi and the milli and whatever else, we can apply them to just about any units we'll see here in the sciences. We'll be talking about moles, and when we get to moles, we'll be talking about millimoles and micromoles and whatever else, nanomoles. And we'll be talking about seconds in terms of picoseconds, nanoseconds, or whatever. If you know the meaning of those prefixes, you can apply them to just about any of the units that we wind up using in here. So again, you need to memorize those metric prefixes. So today, we're going to work with those metric prefixes a little bit. If you don't have those metric conversions out, you might want to get those out. Those metric conversions appear on page 17, it appears in your text. And let's go ahead and practice some of those. Now you might actually know your metric prefixes better than you think you do. So one example I'm going to give here, where you've used them already, is the prefix centi. Prefix centi. So let's say that we talk about units of dollars and centidollars. Dollars and centidollars. And of course, centidollars in the US, we call it cents for short. And so we want to put in a couple conversions. Now, if you look up those conversions, again, the prefix centi means 1/100th. So then, if we wanted to write this in, we could say for every $1, there's how many centidollars? There are 100 of those. And if we add 1 centidollar, that would be the same as 1/100th of a dollar. And so you've used this your entire life. You know that there's 100 cents in $1, and you know that 1 cent is the same as $0.01. Of course, in the US, we put the dollar sign out front. You go to other countries, you'll see they put their currency symbol on the back end. Okay, but we've used this our entire lives, many of us here. So now, if we then went over and wanted to have a conversion, let's say that we wanted to convert meters to centimeters, and don't blurt out the answers here, or centimeters to meters. I believe I have these on the Socrative app, so let's go ahead and check these out. See how you do on this first one here. We are going to see if you can convert meters to centimeters and centimeters to meters. And you'll see your choices here. Again, talk with a neighbor. Remember, you always sign into Chem Lancer. Your name isn't your name in here. Your name is your element, your symbol. Because it's going to save time, because I know you get kicked out of this often, and if you get kicked out and you can't get back in, don't obsess over it, just forget it for a day, all right? You don't have to worry about obsessing whether you can't get in, because that's as bad as snapping or Instagramming or whatever else you do. And you're not paying attention. Okay, so let's check these out. We'll count down. 5, 4, 3, 2, 1. Very good. So what I would say then to remind you is this, and this will always work. Doesn't matter which direction you're going, as long as you learn the meaning, the way that things will all, and it doesn't even work with just the metric system, it works in any size units. And that is, you find the smallest unit between the two. So between the meter and centimeter, the centimeter is the smallest unit. And the smallest unit will always be attached to the largest number. Always. In this case, the meter being the larger unit is attached with the smaller number. And again, that if we're talking about inches and feet, that's the same thing. They always work that way. So we'll try a couple more here. And if you don't know your prefixes, look them up. Let's convert milliliters into liters. And let's convert kilograms into grams. So once again, look them up, and first one appears, it's the milliliters to liters. And if you need the conversions, I guess I can put them back up here. Here's your conversions. So remember, larger number goes with the smaller unit. Smaller number goes with the larger unit. Always. So if you know the prefix milli, stands for 0.001. And always feel free to talk with a neighbor if you're not sure. So let's get our answers locked in, please. Count down, 5, 4, 3, 2, 1. All right, it is the first one because milli is 1/1000th. And the mill, now see, let's say you've been out running. Here's a way to think about this. If you've been out running and I offered you some water, do you want a milliliter of water or do you want a liter of water?
I'd like
You'd like a liter because it is bigger, okay? So that means that the bigger unit's going to be attached with the smaller number, okay? And it will always work that way. So the next one, think about gold. I'm offering you a gram of gold or a kilogram of gold. Which one do you want? I'm going to give you a gram of gold or a kilogram. Which one are you taking? Gram of gold or a kilogram of gold? And go back to your meanings. Kilo stands for 1,000. So get your answers locked in, please. And we'll count down. 5, 4, 3, 2, 1. And that's going to be 1,000 because kilo means 1,000. Because of course if you want gold, which one do you want? I'm assuming you want a kilogram. So even if you don't know how big it is, I think most of us know that the kilogram is bigger than the gram, right? And so since kilograms is a bigger unit, it's going to be attached with a smaller number. Smaller unit is going to be attached with a bigger number. Will always work that way. Always. So you just need to memorize your prefixes. Any questions on the quick intro here on those SI units? Okay, next up, we have the next thing we're getting into in here is dimensional analysis. We're going to be converting some units. So take this conversion and see which units you wind up with. Take these units. See, what do you wind up with for units on this problem? And you have a slash key on your phone, on your whatever they are, your keyboards. You should. So what are the units if we went through this calculation? We're not looking for numerical value, we just want to know the units. Anybody need a periodic table and conversion sheet today? We're going to be using conversions next. Anybody need their conversion sheets? No. Anybody else? There's two down there. Down there. It's in your syllabus. So if you have your syllabus, you should be able to pull it out. Anybody else need one? Let's check out how we're doing here. We got 29 of you locked in already. So if you went through this, let's just do this real quick. Cancel out units. Which ones cancel? Pounds? Kilograms? Cubic feet? Cubic centimeters, so you should get grams per milliliter is what you should wind up with. Very good. Not grams times milliliters, it's grams per milliliter. So very good. Looks good on that one. All right. So now we want to do some conversions. And remember, you're going to memorize the metric to metric conversions. But if you have the conversion sheet, which I'm going to go ahead and pop in a copy here of the conversion sheet for us to use today. Remember that these English to metric conversions are good out to 4 significant figures, that your English to English conversions are exact. If they're exact, this means they have how many significant figures? Infinite number of significant figures, exactly. So it's infinite sig figs. And I don't know what's happening to my What's happening to my spots? It's like they are just disappearing. You see that? That's like really weird. All right, but we can go ahead and do some calculations with this. So the first thing we're going to do here today is to convert your weight in pounds to units of kilograms. So express your weight in pounds. What is going on? Okay, I'm going to close that, and I'm going to open it up again. I'm just wondering if I'm resting on a keyboard or something here. I don't see that. Let's try it again. Express your weight in pounds. That was like really weird. Or convert, I should say. Pounds. I can just say then convert to kilograms. Now, of course, physicists have a little trouble with this. And why are physicists? I know somebody had physics. Why would they have trouble with this? Because pounds measures weight, kilograms measures mass. Okay? It's a bad habit of chemists, and we know better. But we assume always that our units are measured here, our measurements are here on the surface of the Earth, even though that's not always true. If we went somewhere else, that would not be a valid conversion. If we were doing this some justice, we would use the SI units of weight. SI units of weight, anybody know the SI units of weight? It's not the kilogram. It's the Newton. Yes, it's the Newton. Or we'd use the English unit of mass. Anybody know the English unit of mass? It's the slug. Okay. Which is short for sluggishness. And so whenever you have a mass, it's sluggish or resistant to force. But we'll assume that this is a valid conversion, even though it really isn't. So we have 1 kilogram is 2.205 pounds. So if we do that conversion, if you want to use my weight, you can. I have 212 pounds for my weight. If I want to do this conversion now, we want to set it up just like we did in our previous example, where if we have units on the top and on the bottom, they cancel out. So if we look at the conversions, what here is going to go on the bottom? Kilograms goes on the bottom?
No pounds.
Pounds goes on the bottom. How many pounds? 2.205. And then on the top we put in 1 kilogram. We set it up like this. The reason we set it up like this using dimensional analysis is so these units cancel out. And if we run through this, somewhere I have my calculator here. Now we're going to take 212, divide this by 2.205, and for mine I wind up with 96 point. And how many significant figures should be in this answer? 3. So I'd round mine off to 96.1 kilograms. So the way that we do this in terms of rounding is we still follow significant figures, even though it's not specified. We have 3 significant figures here. Remember, this conversion has 4 significant figures. The fewest of 3 and 4 is 3. So we round this off to 3 significant figures. Let's do another one. Let's start with something like 65 miles per hour. And we'd like to convert this into SI units. I want to convert this to SI units. Now, if we're going to convert this to SI units, you need to know what SI units are of length and time. So what is the SI unit of length?
Meters.
It's the meter. What is the SI unit of time? It's the second. So that means we need to convert this to meters per second. Okay, we need to convert this to meters per second. So sometimes you'll see in your homework, convert to SI units. You need to know those SI units. If you don't know those SI units, we go back to where we were here the other day, and this is a list of what those SI units are. And case you're curious, the SI unit of mass is not the gram, it is actually the kilogram. And the reason for that is because it turns out that 1 liter of water has a mass of 1 kilogram. Okay, so that's kind of where that kilogram came from. All right, so now if we want to do this conversion, we come back here, and the biggest mistake when we work with things like these is that students like to write it just like this. And if you write it like this, half of you are going to wind up getting this problem wrong. What is the best way to write miles per hour?
65 miles over 1 hour.
Right, you're going to put it miles over hours like this because you want to keep the numerator and the denominator straight. If you leave them both up there to make it look like in the numerator, you're going to have some problems. And of course, that means we're going to calculate units of meters over seconds. So now let's go through these calculations and see what we wind up with for units. Now it doesn't matter whether we start with the numerator or denominator first. Let's start with the numerator first. We can convert miles to which units? Meters? Is that one that works? I don't think we have meters here. What's one that would work?
Kilometers.
Kilometers. So we have 1 mile is 1.609 kilometers here. So we can come back and put in 1 mile for every 1.609 kilometers. Where is the 1 mile going to go? Mm-hmm. And why do we put it on the bottom? So the units cancel, which means on the top we're going to put in 1.609 kilometers or kilometers. Now the beauty of dimensional analysis is we can set this up in one problem. So we'll take it one more step. We have kilometers, we want to get to meters. So we need a conversion between kilometers and meters. This is not going to be anywhere on your conversion sheet because this is a metric to metric conversion. The prefix kilo means 1,000. That's a to memorize value. So we're going to put kilometers on the bottom. We're going to put meters on top. If kilo means 1,000, if I'm going to set you out for a run, which one's the easier run? 1 meter, right? That's this much. Some of you might like to do that, okay? Some of you might not like to go a kilometer because this one is? Right, it's 1,000 meters. So always ask yourself, which one's bigger? So put it in the context, like we did with the gold. Do I want a gram of gold or a kilogram of gold? If you don't know, if you know the prefix is 1,000, always ask yourself that question. So prefix is 1,000, it goes with a smaller unit. Kilometers here cancels out. If we stop now, our units would be meters per hour. So we can keep going with this one and convert now the hours to seconds or minutes. Let's do minutes first. So if we want to convert minutes to hours, what do we put on top? 50 minutes? 60 minutes. Where's the 60 going?
On the bottom.
Here, top and bottom. On the bottom, right? And that's because for every 1 hour we have 60 minutes. We set it up this way to get those units to cancel out. And then our last conversion, on top would put in
1 minute.
1 minute, on the bottom
60 seconds.
60 seconds. And again, units and minutes here cancel out. So now go ahead and run this through your calculator, please. And while you're doing that, I'm going to set this up a different way. How many significant figures should be in that answer?
2.
2. So out of the 2 significant figures, we are winding up with 29. The label there being meters per second. 29 meters per second. So the quick way as you go through this, and we looked at one of these here the other day, the quick way to do this is to multiply all the values in the numerator. So you take 65 times 1.609 times 1,000. Then you would divide by 60, and you would divide by 60 again. Okay, so now, let's say that you chose to do it another way. Let's say instead of doing this because you don't want to do 2 conversions, you just want to do 1, we want a conversion from hours to seconds. What number do we put on top?
1.
And on the bottom?
3,600.
3,600. And I'll be sure that when you do that, you don't put in 60 seconds in an hour. Okay, so the seconds stay there. What am I canceling out? Hours, right. So then another thing we could do then is instead of converting to kilometers like we did here, the first thing that came to mind was to convert it to feet. So if we come back to our conversions here for feet, this is an English to English conversion. So we see 5,280 feet in 1 mile. What does the 5,280 go? On the top. And then on the bottom, this is for every 1 mile. How about this conversion here? Where do we find this one? English to metric conversion, exactly. So you come back and you're going to see the English to metric conversion right here. 1 meter is 3.281 feet. So where does the 1 go? Here top or here the bottom? Goes on the top because the conversion here says 1 meter is, and then that's equal to 3.281 feet. So we put that on the bottom. Let's run this through your calculator and see what you wind up with. Or maybe you've done that already. Units all cancel. You see we're left with meters over seconds. Meters over seconds. Well, or do we need to calculate this? Out to 2 significant figures, what do we get?
29.
Yeah, it should be the same thing because all of our conversions are correct. The point here is we can calculate our answers many ways. There isn't always just one right way. Sometimes there's many right ways to do it. So if you are going through and looking at solutions and you say, well, I didn't do it this way, whatever, that's because in many cases there's multiple ways to arrive at the same result. Okay, let's try this one. This one is on your Socrative app now. We're going to take 1 trip around the track. So your track and field. How long is 1 trip around the track? 400 meters. 400 meters, all right? So in my day, though, we didn't use metric units. We used English units. So what was that distance around the track when I did it in units of yards? So go through and convert 400 meters to yards. I put this decimal point in here to tell you that these trailing zeros are significant. So your answer should have 3 significant figures. So go ahead and calculate this. Meters is how many yards? If you have any questions, I'll walk around. And I still have plenty of calculators up here if anybody needs one. Need one? I need some collateral, but I'll come back to you. Always good to compare answers with another person or two before you commit yourself. All right. Okay, your name isn't Chem Lancer, that's me, whoever borrowed that. Okay. And sulfur, you should be putting S in. All right, sign in with your symbol, not with your name. I'm Chem Lancer, nobody can use that. Haven't trademarked it yet, but I will, in my retirement.
This is how I wrote it out. Well, I'm not sure if I'm doing
If I trademark it first.
calculations.
Better not.
I just tend
I'll hunt you
sell
down.
you the rights.
I'll hunt you down.
I got 137, but I don't know if I'm right. I did something similar to that, but
All right, we've got 36 of you. Let's check out the answer here. 437. Very good. 437. And of course, the track wasn't 437 yards around. I actually ran a 440.
things like 400 meters.
40. A 440 is what we used to run. And a 440, it turns out, is a quarter mile. So I heard somebody else mention a quarter mile as a distance around. That's really kind of what it used to be. It's a little bit shorter. What is it? A little bit shorter today because the 400 meter is 437 yards. All right, we're going to move on to the next one and see how well you do with this one. Which weighs more, a pound of feathers or a pound of gold? What do you think? Always talk with a neighbor. Let's get your answers locked in. We'll count down. 5, 4, 3, 2, 1. All right, should be neither. They're the same. It's a trick question. Very good.
Yes.
Yeah, I don't. You can't fool me. All right, nice try. Thank you. Thank you. Darn it. All right, well, very good. So they're the same. What do they differ in, though? Density. And what else do they differ in? Volume. Which one's going to have a greater volume?
Pound of feather.
Pound of feathers will. And a gold of lead's a pound of lead. Pound of gold.
What is this?
Pound of gold. See, it's trick, right? Pound of gold is going to be pretty darn small. So yeah. So now we're going to look at density, and one of the ways to look at density is using a formula, which I think most of you ought to know by now. What is that formula? Mass over volume. And that's because we give a definition of density as being the mass per unit of volume. Mass per unit of volume is how we define it. And so if we haven't learned, we're going to use this terminology a lot throughout the semester. Mathematically, the word per means to
Divide.
divide. So we divide mass by volume, as we've said here already. So one way to do it is say D is equal to M over V. So I got a block of wood. We're going to measure the density of this block of wood. What do we need? Okay, where are we going to get the mass?
You gotta.
By weighing it, sure. Geez, I have it right here. How convenient.
Wow.
So we'll check this out, and we'll put it on the balance. Of course, it's reflecting up here, and iris is closing on the lens. So we'll back it up a bit. There we go. So we'll zero it here and pop this on so you can record its mass. The mass of this block of wood is 256.7. It's like the same thing's happening to this as my screen. Okay? That's like really weird. So 256.77. So 256.77 is where we're going to go.
It's too drafty.
It doesn't feel like it. Okay, how are we going to get the volume for this? Stick it in water. I don't have a big enough beaker. How else could I do it?
Yeah, you do it. It's right there.
Oh, okay. Not precise enough. No units. No units. Okay, I lied. There are units. Not big enough. What's another way?
Length times width times height.
Right, length times width times height. I had this right here, my little props, okay? So, now probably the best way when you do this is to not start on the end mark because, I mean, this is kind of shaved off, so we'll start on the 20. Looks like it goes up to about 37.2. So that's going to be 17.2 centimeters. 17.2 centimeters. And then we need a width, which will go from 20 on over. Looks like this sits at about 8.6 centimeters. 8.6 centimeters. And then we need its height, which, how about I just lay it down here? Of course, I'm not wearing my reading glasses today, but I think we get that. Looks like it's the 7th mark after, so that'd be 3.7. 3.7 centimeters. So let's go ahead and calculate that density. Water displacement would work, though, for those that mentioned. Of course, we'll talk about what we'd have to do if we would use water displacement on this. I am interested to see what we come up with on our calculators. I'm coming up with an answer of 0 point. And how many sig figs should the answer have? 2. So I have 0.47. The label is grams per cubic centimeter. So these are your units. Okay, and I don't have it shown up here, so let's try it. How about put it back up here? Come on. There we go. So 256.77 divided by 17.2. So when I set mine up in the calculator, I take this, divided by this, divided by this, divided by this. So 0.47 grams per cubic centimeter. Any questions on that one? Yes, Jacob?
Wouldn't measuring the volume by water displacement be inaccurate because wood absorbs water?
True, and there's the other issue here. First of all, let's talk about this issue. It is true that it absorbs water. How could we, one of the things you should do when you calculate an answer is ask if it makes sense, and I've been forgetting to ask you that. How could we look at this and say that this answer makes sense?
Because it would float on water.
Floats on water, and how would we know that this makes sense if it floats on water?
Because it's lower than the density of water.
What is the density of water?
1.
1. So that's what we need to do, is we need to ask ourselves, how does it compare to a density of 1? Talk about the density of 1, that's units of grams per cubic centimeter. Turns out for water, 1 gram of water has a volume of 1 cubic centimeter at 4 degrees Celsius. So, but as an approximation, we can always use it as the density. And so what we know about wood is that wood typically will float on water, so its density should be less than that of water. If you calculate a density, now some of you, I'm sure if you set it up like this, would have taken this divided by this times this, you would have gotten this really big answer. If you got this really big answer right away, that should tell you you did something wrong. Now some densities that you have available to you. This is on page 19 in your text. So when it comes to exam time, you would be supplied a table of densities. Don't memorize these. If it comes to your mastering chemistry and they'll say you'll calculate an answer and it might ask you, does this seem reasonable? Well, if you calculate a density for, say, aluminum and came up with something like 2.67 grams per cubic centimeter, you could say that, yeah, that probably makes sense because it's supposed to be 2.70. So just remember that this is available and in your text. This is on page 19, this table of densities. Okay, let's try another one. Let's express this density in SI units. Let's express this density in SI units. If we failed to mention the other day, SI is the French interpretation of the International System of Units. So we don't write it as IS, but SI. So we want to express this in SI units. So what are the SI units of density? Numerator is going to be kilograms. Denominator would be meters cubed. So we want to express it in units of kilograms per cubic meter. Let's go ahead and do that. We want to convert this to kilograms per cubic meter. So now we'll start with the 0.47 grams per cubic centimeter. We'd like to get over to units of kilograms per cubic meter. Well, now we will convert numerator and denominator one at a time. Let's convert the numerator first. Grams here are going to convert to kilograms. So on the bottom we'd put grams, on the top we'd put in kilograms. Remember now that the prefix kilo stands for 1,000. So where's the 1,000 going to go? It's going to go on the bottom. And it's going to go on the bottom because gram is a smaller unit. The smaller unit always gets the larger number. So grams are going to cancel out. This gives us grams per cubic centimeter. We now need to take another step. Our next step, we want to convert centimeters to meters. So what are we going to put on top? Centimeters, and on the bottom, meters. The prefix centi means 1/100th. Now I don't know about you, but I don't like using fractions. If I can use a bigger number, I'd prefer to use 100 instead of 1/100th. So if we use the number 100, is 100 going to go on the bottom or on the top?
So
Go on the top. Because a centimeter is a smaller unit. The smaller unit, it gets the bigger number. Okay, now this isn't going to cancel out completely. We need to do one more thing to this conversion. We have to cube it. Now sometimes when students cube, they forget how these cubes work. So let me remind you here. First of all, this cubic centimeters is going to cancel here. That's just going to cancel with the centimeters in here. It does not cancel out the cube on the outside, because the cube still has to be applied to the meters, it still has to be applied to the number 1, it still has to be applied to the number 100. So at this point, let's go ahead and calculate that answer. You're going to take 0.47. You're going to multiply it by 100 raised to the 3rd power, and you're going to divide that by 1,000. And so if I were to show you how that looks on my calculator, before I hit the... So you see how I have that set up? I'm taking 0.47 times 100 raised to the 3rd power. I'm dividing that by 1,000. I hit enter, and I wind up with an answer of 470. Now, of course, if we see an answer of 470, answer 470 has an ambiguous number of significant figures. We want this answer expressed to how many sig figs? 2. So we'd write that answer as 4.7 times 10 to the 2nd kilograms per cubic meter. The average human body has this density. Average human body has a density of 1.03 grams per cubic centimeter. Let's convert this to English units of pounds per cubic feet. Figure out what your density is, at least on the average. Some people are more dense, some people are less dense. If you're really bony, you probably have a little bit higher density. If you have a little more weight on you, you're probably a little bit less dense.
If you still don't know your prefixes, you're probably more dense.
All right, so go ahead and do this, and this is up on Socrative. Remember, you're probably going to be doing some unit cubing. Help each other out. If you get stuck, don't sit here and get stuck by yourself. Before you commit to an answer, ask yourself if it makes sense. Think about how big a cubic foot would be. Cubic foot's going to measure 1 foot by 1 foot by 1 foot. And the question always is a good one to ask. Does an answer make sense? I've had people tell me on their exams that snails travel faster than the speed of light. I've had babies weigh 5,000 pounds. Let's see, we have 10 people logged in on it already. Let's take about maybe 2 more minutes. Get 15 of you with answers.
Hey, excuse me. So I think I got the kilograms.
On the bottom, remember when you have this one,
453 kilograms, but now I'm thinking about not converted to
on the bottom, then the centimeters of it.
That's what I'm asking. How do you think you do that? Because 1 meter is 3.28 feet. So a centi is, that was 100.
I'm used to centimeter is there's actually an easier way. 1 feet is 30.48 centimeters.
Oh, really?
Yeah.
Yeah, I don't see that.
That means
All right, we got 22 of you. Let's take 1 more minute.
Yeah, that's more direct.
Remember, your key on this is to write grams in the numerator and cubic centimeters in the denominator. And we're putting pounds over cubic feet over here. All right, we're going to check out those answers. Let's see how we did. If you want to get yours in there, I'll count down here. 5, 4, 3, 2, 1. Correct answer is 64.3. 64.3. Very good. And if you set it up properly, there's actually multiple ways you could do this. If we want to convert grams to pounds, there's a direct conversion for that. Where do we put the pounds?
On the top.
On the top. For every 1 pound we have 453.6 grams, and that comes from your conversions right here. You put that in, which units cancel? Grams. And then, is there conversion between centimeters and feet?
Yep.
Yes, there is. And so where are we going to put the centimeters? On the top. On the bottom we put in feet. Our conversions tell us right here. For every 1 foot, there's 30.48 centimeters. So where does the 1 go? On the bottom. The top we put in 30.48. To complete this, what do we need? We cube it. And then units would. And how much cancels out? Just the centimeters there. The whole cube goes out here. But when you calculate this, you need to remember that you take the 30.48 and you cube it. Okay, any questions on this one? So that means if there was a cubic foot of you, that is a box that measured 1 foot by 1 foot by 1 foot, that box would contain 64.7 pounds of you. And so if you're like me and weigh about a little over 200 pounds, I could actually figure out what my volume is in cubic feet. I'd find out that I'm 3 point some cubic feet in terms of volume. Okay, let's do these next ones. We're going to wrap up chapter 1 with some temperature conversions. These are the conversions you need to do. 25 degrees Celsius is how many K? How many kelvins? Temperature of negative 40.0 degrees Celsius is, not Celsius, Fahrenheit, sorry, is how many degrees Celsius? And a temperature of positive 37.0 degrees Celsius is how many degrees Fahrenheit? Now if you're going to do these, you have those conversions right here. These are exact conversions, which means these have no bearing on significant figures. Your significant figures and your decimal places will come from your calculations. So let's go through, and I'll have these are the last 3, I believe, on the Socrative app here today. Can work with neighbors. And we will knock these off in succession in about 5 minutes. And then I have a demo to wrap up the hour today. You must follow your rules for significant figures and rounding, or decimal places if it's appropriate.
Negative 40 for the Celsius conversion?
Yeah, but I negative 40.
You need the correct number of decimal places or significant figures.
Me too. That's why I do this one.
Yeah. Did you get 3 times 21 after Fahrenheit?
98.6. Let me just try that one more time.
If you're not sure how to do it, ask somebody that knows how. First one's easy. The next 2 are, some of you, a little more challenging. Give you about 3 minutes to finish all of them. 3 minutes to finish all of them. And if you disagree with a neighbor, figure out who's right, who's not. Figure out sig figs. Take about 2 more minutes.
Was that determines the number of significant figures of your answer again?
Well, your order of operations. You need to know your rules. So the addition, subtraction, what do we look at?
Was the 0 least one decimal places? The answer has to have that
correct. So your first one follows addition. So that means that if you have 25, this one needs decimal places.
Zero decimal places.
Your answer should have.
Zero decimal places.
That's correct.
Multiplication numbers has the same number of sig figs as the number of sig figs.
Correct. Yes. And so when you mix up operations in here, then you follow your order of operations. You do the multiplication and division first,
Okay.
then apply the rules of sig figs. And then you're going to add, but you apply the rules of decimal places.
Okay.
So when you mix operations, there's these rules that apply to your order of operations.
So plugging in the substitution, the decimal part of your substitution has to have.
Start with 3 sig figs. Your answer would have. This part of the answer would have on your sig figs. 3 sig figs. And then you're going to do the next step, it's going to then you're going to make sig figs. But then you're going to use decimal places when you do the next one. So the answer had one decimal place, and then
Oh, your answer for this particular part of the problem would add 3 sig figs.
for that part of the answer, right?
Yeah.
But then when you go,
Yeah, and then when you add this to that one, the answer for those two is going to have no decimal places.
actually, this is an exact conversion. So this, when it's exact, you assume it's 32.000 on into infinity.
Okay, so
All right, let's take about 10 seconds here for the first one. We'll count down. 5, 4, 3, 2, 1. Correct answer is 298. 298.
Shouldn't it be 2 sig figs?
No, not going to be 2 sig figs because what operation are you using in this one?
Addition.
Addition. In addition, we don't look at sig figs, we look at decimal places. We look at decimal places. So 25 has 0 decimal places, that means your answer has 0 decimal places. Okay, let's check out the next one. Get your answers keyed in. Negative 40.0 degrees Fahrenheit is how many degrees Celsius? I'll give you about 10 seconds to get it keyed in here. You should have done these already. And we're going to count down. 5, 4, 3, 2, 1. Correct answer here is negative 40.0. Negative 40.0 is the correct answer here. And that's because if you look at the formula for this one, the formula on this one shows that this is exact. And now we have mixed operations. So if we have mixed operations on this one, if it's exact, this isn't just 32. This is 32.000 on into infinity. Okay? So you would take negative 40.0 minus 32, which is going to give you a negative 72.0. You will then multiply it by 5/9. Once you go to multiplication, you then use the rules of sig figs. So negative 72.0 has 3 sig figs. You multiply by 5/9. Your answer should have 3 sig figs, so it's going to be negative 40.0. Okay, then the last one here. Let's check out the last one. Get your answers locked in. Oh, and by the way, I picked that last one because it just baffles people. How could they be the same? How many retried doing the calculations? They found it was wrong? Yeah. You try like 10 times and you keep getting the same answer. That should tell you you are right. And there's almost always one question like that on an exam. It's not a trick question. It's just to verify that, yeah, I'm doing it right. Okay?
It's to make you second guess yourself.
All right, let's get your answer. We're not done yet. Don't pack up. We've got 5 minutes left. So let's count down here. 5, 4, 3, 2, 1. The correct answer is 98.6. I picked this one because this one is normal body temperature. If you go to a foreign country, it's important that you know that if your temperature is in excess of 37 degrees Celsius, you are running a fever. It's 98.6. So in terms of how you would go about calculating this one, let's see, where's my conversions? This one here now we are converting over. First step, let's see, we're doing this one right here. So we're going to do the multiplication first. We take 9/5 times 37.0. Our answer is going to have 3 sig figs. My recollection is that number is 66.6. Because this is an exact conversion, this has an infinite number of decimal places, 32.00000 on into infinity. So we take 66.6, add to it 32, and we get 98.6. Any questions? All right, last thing we're going to do is we have a demo here today. And I walked around a bit and I put down some strips of tape. If you had me for 1020, you've seen this one before. But we are moving on into Chapter 2 here next. And in Chapter 2, Chapter 2 is going to depend a whole lot on our knowledge of charge and how charge interacts with each other. So what I'm going to do with these two pieces of tape, and I put a piece of tape down the center here, I put some on the end and over here, and the people that are sitting on the end are going to be your demonstrators. And what I'm going to do then is I'm going to put these strips of tape down on the table. I've made some handles. You want to make sure that the tape is very securely attached to the table itself. And we are going to make these pieces of tape acquire charge. Now, since I've been doing this for 30-some years, you'd think I would know what charge it has, and I don't know. And actually, it turns out it doesn't matter. But what I do know is kind of how the charge is in relation to each other. And so now, if I rip these pieces of tape up off the table, I'm treating them in an identical manner. And let's say that the table is something that gives up electrons. If the table is something that gives up electrons, that means that each of these pieces of tape will have picked up electrons, and their charges are going to be the same. They're negative, but they're both going to be the same as each other. So let's say that I was wrong. Let's say that the table is something that takes electrons away from the piece of tape. The table takes electrons away from the piece of tape. At the end, if I rip the tape up off the table, I've treated them identically. In the end, both of them are still going to have the same charge as each other. So let's go ahead and rip them up off the table. Grab the handles and rip them up. And once you do that, what we're going to do is we're going to bring the two pieces of tape in the vicinity of each other and try to push those two pieces of tape together. And if you try to push those two pieces of tape together, what happens to them? They repel each other, right? Okay. So, lesson 1 here today is that like charges will repel. Pass these on to another person in your row. Doesn't matter who. Somebody who's next to you or a couple chairs down. Now what we want to do is we want to make these pieces of tape have charges that are opposite of each other. So to make them opposite of each other, what we're going to do is we're going to take the two pieces of tape and attach them to each other. You can put sticky side to sticky side, but they're difficult to get apart. So I like to put sticky side to smooth side. Just put the two together, again, sticky side to smooth side. Leave yourself the handles here. Okay, once you leave the handles, if we say that one piece of tape gives up electrons, that means the other piece of tape will gain electrons. If one loses, one gains. The charges should be opposite of each other. So let's make the charges be opposite. Let's rip them apart. And then go ahead and put them up next to each other. This one's kind of anemic. But you should see that the two pieces of tape will attract each other. I think I put sticky side to sticky side was my problem. And so the lesson in all this is, like charges will repel each other, opposites will attract. Remember that for Thursday?